My name's Chad Morin. We're here today with Empowering Brands, just doing a site visit for Gould solenoid valves, going over a little bit of how the valves are built here. So we have cast bronze, stainless steel, and 316 stainless steel valves that can all be made accordingly to what the pipe size, pressure range, media is going through. So here you see some of the piston assemblies that are machined here in-house in Indianapolis. We've got our standard brass, we've got some nickel plated, we've got Teflon coated for certain applications where it might be a corrosive environment. And from those, we can go to our elastomers, and for general purpose stuff, just do Buna, Viton. We do EPMD and ethylene propylene. This would be Teflon, which is good for high temp, for corrosive fluids, or for high pressure applications. So it allows us to take one piston assembly and either make it a air-water valve, an oil valve, a steam valve, a valve up to 125 psi or 1200 psi. So it allows us a modular system to where we can build a custom-made valve and get it out the door within one day, to where most people are weeks for something like that. A standard 1-inch bronze cast body, and this allows us to take the pistons that we just showed you, and again for a general purpose would just be a air water type valve with a Buna and a Viton seat materials, or we can take this same valve body, do all Teflon with a high temp coil, and make it for a steam valve or a corrosive fluids valve, and get everything out of here within one day of receipt of order. And we've got two styles of coils. For our M series valves, they all come standard with a NEMA 4X coil. So this coil is already waterproof, corrosive resistant. All our Q, K, and D valves come with just these molded coils, which would be a standard NEMA 1 and a can coil assembly. But we can also make this coil meet the NEMA 457 watertight, dust tight, explosion proof by using the cast iron enclosures we showed you earlier. So again, another way that we can make one coil usable for multiple applications. Alright, and these would be our coil enclosures that are machined out of cast iron that would allow our standard Q and K valves to be NEMA 4, 5, and 7, which makes it watertight, dust tight, and a class 1 Div 2 explosion proof, which means that it will contain a spark in case of a failure to eliminate an explosion, anything in a caustic environment or a volatile environment, and keeps everything self-contained into the unit. That's like the coil that we showed you, and just a standard NEMA 1. Just a standard 1.5-inch bronze valve. Break that apart. How it was a rough casting, and how everything would be burnished.
Gotcha.
How smooth and precise the seat would be.
The
Correct.
tolerances.
That's where it's going to sit down. The body bore going up, and machine in the ends.
Very
and
cool.
there's again not many people in the industry that do a 2.5 and 3-inch. And we even used to make a 4-inch and quit doing that
Wow.
10, 15 years ago, just because the demand wasn't there. This is just a general purpose valve for air and water, 1.5 inch, 10 to 200 psi. Gives you all your info in there. Just a 120 AC coil and a NEMA 1 enclosure. What you first watched Tracy doing was the bonnet plate to the tube together. The tube plug that Ed and Tullis were making on the other side is what gets welded down into the top of the tube. When you energize the valve, you're pulling up this pilot assembly into this tube and into the center of the coil, into the magnetic field, which allows the media to run through here, pops this piston up, and allows for full flow through the valve. And essentially it just reverses the process. When you de-energize the valve, drops this back into here, starves the valve off, and closes it completely. So with a spring assist. And standard on our valves would be, as soon as you energize it, it should be fully open within a half a second. And same thing as soon as you de-energize, fully closed in a half a second.
Awesome.
You know, it's just an expander in there that's a Teflon outer ring over a stainless steel ring that takes any slop that would be in between that piston and the body bore out of there and keeps it tight in there.